Hello friends, myself already Mahajan presenting my video on numerical differentiation. Let us try to solve the problem. Find dy by dx and d2y by dx square at 0.2 for the given data. That given data is values of x are 0, 1, 2, 3, 4. Difference between two successive values is 1 equispaced, and the corresponding values are 2, 5, 10, 14 and 19. And therefore, to find out this differentiation or the values of dy by dx and d2y by dx square, first step we have to prepare the forward difference table, and then in second part we have to apply formulas to find out that dy by dx and d2y by dx square. Therefore, first preparing that table, preparing that forward difference table. First difference del y, 5 minus 2 we get 3, 10 minus 5 we get 5, 14 minus 10 we get 4, and 19 minus 14 we get 5. These are the first forward differences. Then differences of these differences gives you second order differences. 5 minus 3 is 2, 4 minus 5 minus 1, 5 minus 4 1. These are the values of del square y. Then differences of this we get third order difference. Minus 1 minus 2 we get minus 3, 1 minus 1 plus 1 we get 2, and the last difference of this is 2 minus 3, 2 plus 3 we get 5. Then we require to find out the value at point 2. Point 2 is in between the 0 and 1, means it is at the top of the table, and as it is top of the table, we use Newton's forward interpolation formula to find out that derivatives, or the formula is obtained from that Newton's forward interpolation formula, and therefore we underline the first value as x0, the corresponding value of y as y0, and the first value, this one as del y0, del square y0, del cube y0, and del raised to 4 y0. Then we find the value of p. It is x minus x0 by h. Substituting the values, a value of x is here 0.2, at which we require to find the derivative values. X0 is 0 from the table, and divided by h, difference is 1. Therefore, 0.2 minus 0, we get that value as 0.2. Therefore, this is the value of p. Then, using Newton's forward interpolation formula, we get that derivation already I have discussed in my previous video. Therefore, using that result directly here, no need to write down that formula of Newton's forward interpolation formula, and then differentiating it. Therefore, that step I am using here as a standard result. Therefore, we have dy by dx is equal to 1 by h del y0 plus 2p minus 1 divided by 2 factorial del square y0. Then next plus 3p square minus 6p plus 2 divided by 3 factorial into del cube y0 plus next term is 4p cube minus 18p square plus 22p minus 6 divided by 4 factorial into del raised to 4 y0. Therefore, this is that result which we have to apply to find out first order derivative, and therefore substituting the corresponding values from the table. Here h is 1, difference between that two success values have 1. Therefore 1 by 1 we get 1. Delta y0, the value of delta y0 is 3 plus 2 into p, the value of p is 0.2 minus 1 divided by 2 factorial is 2 into del square y0 is 2. Next term, it is 3 into p square, 0.2 square, minus 6 into 0.2 plus 2 whole divided by 3 factorial, that is 6, into del cube, the value of del cube y0 is minus 3. This is the third term. Fourth term is 4 into p square cube. P is here 0.2, it's cube, minus 18 into p square, 0.2 square, plus 22p, 22 into 0.2, minus 6, and whole divided by 4 factorial. The value of 4 factorial is 24 into del raised to 4. The value of del raised to 4 is 5, and so on. We stop here as this is the last value, and then simplifying it we get that value as 1 by 1 we get 1, therefore it is 3. 2 into 0.2, 0.4 minus 1, 2 to get cancelled, therefore 0.4 minus 1 minus 0.6. Then by calculator, if you simplify this, 3 into 0.2 square minus 6 into 0.2 plus 2 divided by 6 into minus 3, that value is minus 0.460. You can cross check it by calculator. Don't write it as it is. Always try to perform the calculation yourself. Then 4 into 0.2 cube minus 18 into 0.2 square plus 22 into 0.2 minus 6 divided by 24 and into 5, that value is minus 0.47, and therefore we get that value of dy by dx at x is equal to 0.2 is equals to 3 minus 0.6 minus 0.46 minus 0.47. Simplified value is 1.47. Therefore, this is the answer. The value of dy by dx at that given point 0.2 is equals to 1.47 obtained by this formula. That formula is obtained using Newton's forward interpolation formula. In second part, we try to find out second value, that is d2y by dx square at 0.2. Then d2y by dx square is obtained by or given by 1 by h square del square y0 plus 6p minus 6 by 3 factorial del cube y0 plus 12p square minus 36p plus 22 divided by 4 factorial into del raised to 4 y0. Corresponding values: 1 by 1 square 1, del square y0, the value of del square y0 is 2. We can take 6 common from this. P minus 1, P is 0.2 minus 1 divided by 3 factorial is 6 into del cube. The value of del cube is minus 3. Next, plus 12p square, 12 into 0.2 square, minus 36 into 0.2, plus 22, whole divided by 4 factorial. 4 factorial is nothing but 24. And del raised to 4, the value of del raised to 4 y0 is 5. Simplifying it, we get the first one is 2 as it is. 6 is get cancelled. 0.2 minus 1, we get minus 0.8 into 3 into minus 3. Next one, 12.2 square minus 36 into 0.2 plus 22 multiplied by 5 and divided by 20, 3.183, and that is equals to 2 minus minus it become plus, it is 2.4 plus 3.18. If we take the addition of all these three terms, 7.583. Therefore, we have d2y by dx square at x is equal to 0.2 and value is 7.583 as the answer. Therefore, in this problem, I have obtained the two values. The first one dy by dx and second one d2y by dx square. For the point 0.2, which is in between 0 and 1, means at the top of the table, and as it is top of the table, we use Newton's forward interpolation formula, and using that results of a derivative. In my next video, I will discuss another example on numerical differentiation. Therefore, if you like my videos, please share it as well as subscribe to my channel to get a notification of my all new videos. For that, press the bell icon. Thank you.